Okay, lesson 1, real functions. The determination of the domain and range, and also discuss the monotony of the function. Okay. The first point in this lesson is about the function. At first, if there is a relation, okay, there is a relation from x to y. Okay, so how can we consider that this one is a function or not? Actually, there are two methods. The first one, algebraically. Algebraically means this relation to be a function, so every value of x, every value of x has unique value in y. Value in y. You know, like what? Like this example, if there is a relation y equal x squared plus 3. Okay, so now whatever the value of x, like if x equal 0, so this means y will equal 3. If x will equal 1, therefore y will equal 4. And so on. If x equal 2, so 2 squared 4 plus 3, 7. If x equal 2, so y will equal 7. So simply this means every value of x, 0, 1, 2, 3, 4, whatever, like that, it will have a unique value in y. Here, 3, 4, 7, and so on. So in this case, we can say that it's a function. So if there is a relation like this, and represented by arrow diagram, which we studied before, x and y, here 1, 2, 3, here 2, 7, 8, 9, for example. And after getting the set of the relation, it becomes like that. One arrow from 1 to 2, from 2 to 8, from 3 to 9. Okay. So in this case, every element of x has only one value on y. So simply this is function, of course. X actually is the domain of the function. So x is the domain of the function. Y is the codomain of the function. Then there are some elements here like 2, 8, 9, which they are the images of x. The image of x on y, here 1, it becomes 2. 2 maps 8. Image means that the element of x maps element on y. 3 maps 9. Okay. So simply these elements, 2 and 8 and 9, the images is the range of the function. So if we want to check if the relation is a function or not, so simply check that every value of x have only one value on y. Okay, like this example. If y equal x squared plus 3. So now, this one is a function or not. If x equal 0, if x equal 1, if x equal 2, if x equal 3, and so on. Y. Okay, so simply y here will equal 0 squared plus 3, 3, 1 squared plus 3, 4, 2 squared plus 3, 7, 3 squared plus 3, 12. So each value on x has unique value on y. Correct, guys? So this one is a function. Okay, another example. If the question is like that, y squared equal x squared plus 9, let's check fx equal 0, fx equal 1, fx equal 2, fx equal 3, whatever the values like this. So here, y squared will equal 9. So simply y equal a quadratic equation here, y to the power 2. So this means that there are two roots, positive or negative square root of 9, which means a positive or negative 3. So we said that each value of x has a unique value. So do I supposed to say 3 or negative 3? There are two values here for the same value of x. So x here, 0 maps 3 and also maps negative 3. So it's not function, of course. We said that it has to be only one value. Okay, so in this case, we can judge that in this question, of course, it's not a function. Okay. Okay, now the next point in this lesson is how to check if the relation is a function or not, but not algebraically, this time graphically. Okay, so graphically means if there is a relation on xy plane, x and y, x dash, y dash, and the relation is like that. Okay, it's given like this exactly. This one is the origin point. So now I want to check if this one is a function or not. So actually, there's a very simple test to know that if it's a function or not. Its name is vertical line test. So what is that one? Actually, I'm going to draw one vertical line to intersect the curve like this. Now, if this line intersects with the curve at one point only like this, so this means it's a function. Okay, try another line like this, only one also, so it's a function. So this curve is a function. I'll keep this one and show you different scenario like this. If the curve in this shape, so now simply, if I want to apply my test of the vertical line, so simply I will find that the vertical line will intersect the curve at 2 points. So more than 1 point, not function. If the line is here, also 2 points. Okay, and so on. So simply, guys, if the intersection at 1 point only, so it's a function. More than 1 point, it's not function. Okay, let's check some examples like this. If there is a relation like this one, and it was represented by a curve in this form. Okay, now my question, this one is a function or not? Very simple, just a Joe, huh? It's a function or not?
Not a function.
Not function, sure?
No function.
Huh? Try to
Sure.
concentrate more. If I'm going to draw a vertical line like
Function.
this, only 1 point. Like this, only 1 point. Like this, only 1 point. Like this, 1 point, and so on, 1 point. So 100% function, of course, right? Okay, guys?
Okay.
Okay, but if I draw one like this, which I drawn before, okay, in this case, simply not function. Intersection point, so not function. More than intersection point. Another one like that. XY plane, and there is one curve of a relation like this. Okay. Now concentrate very well. I'm going to draw one vertical line. Okay. If it was here, only 1 point, okay? If it was here, 1 point, okay? If it was here, 1 point. But if it's here, it's several points of intersection, correct? So this not function. Okay, guys, clear? So if the intersection in 1 point, it's a function. If the intersection more than 1 point, so not function definitely. Okay?
Okay.
Any questions? Any questions?
No.
Okay. Okay, great. The next point, if there is a relation y equal 4. Okay. So y equal 4 means what? If I wanted to represent this one on the number line or on xy plane, so this one xy plane, x, y, x dash, y dash. Now, I'm going to represent this one on xy plane. It's y equal 4. Okay. So this means it's a constant function, correct? Because always y will equal 4. Okay. So in case of representation of this one, we will represent it by a horizontal line passing through y equal 4. So if this one is 1, 2, 3, 4, so simply the function will represent it in this way. Okay, I will change at this point and make it 4 like this. Because here always y is a constant and its value will never change. It's always equal 4, y 4, always. But x is different, of course. 1 and 4, 2 and 4, 3 and 4, 4 and 4, 5 and 4. So y is constant. So now we represent this one, okay, by a straight line which is parallel to x-axis. Okay? The second point, if x equal 4, how to represent this one?
Parallel to y-axis.
If this one x equal 4, so in this case I will draw xy plane. Now x equal 4 means always the value of x is 4. So this means it will be a vertical line parallel to y-axis and passing through this point, correct? Correct, guys?
Okay.
Okay. Now my question, on the first case, look at the board on the first one, y equal 4. If I want to make the test to check if this one is function or not, simply vertical line, 1 line, vertical line, 1 point, sorry, vertical line, 1 point, always 1 point at the intersection. So it's a function. But here, if I'm going to draw a vertical line, the vertical line will become like this. It will be coincident on the line of the function of the relation, correct? So there is infinite number of intersection points with the relation, correct? This point is intersection, this one, and so on. So this one is not function. Okay. Any questions? Any questions?
No, mister.
Okay, so the domain, the first type, constant function. Second type, linear function. Third, quadratic function. Of course, constant function means it's 0 degree. And linear function, first degree. Quadratic, second degree. Examples. Constant function like f of x equal 7. So this means whatever the values of x, y will equal always 7. So in this case, the domain equal real numbers. So we said that domain means x. So whatever the value of x, even if it's all the real numbers, we will get the value of y, which is equal a constant value always here equal 7. Okay? And we said that f of x equals 7 means the representation will be a vertical line parallel to y and passing through this point 7. So here, x always equals 7, but y is different. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, and so on. Okay. 1 second, guys. The next one, it's the linear function like this, f of x equal to x plus 1. In this case, domain equal real numbers. Okay. Quadratic function, f of x equal x squared minus 4x plus 3. So this means the domain also here will be the real numbers. So always the domain is real numbers, yes, if there is no condition in the function. But I'm going to talk about the linear function with a specific condition like this. F of x equal to x plus 3 and x smaller than or equal to. What will be the domain? Here, it's a given in this question that x smaller than or equal to. So x means it's the domain. Now, check on the number line to understand this point. If this point is 0, 1, 2, 3, and here -1, -2, -3, therefore, x smaller than or negative or equal to, so this means starts from this point and smaller than this point, so towards the negative infinity. So this means the domain includes number 2 towards negative infinity, like this. So simply here, according to the given condition, x smaller than or equal to, the domain equal all possible values of x. So we said that it starts from here till negative infinity. This one, we can represent it by using the intervals, of course. And we said before, intervals, 2 elements, we have to start with the smaller one. So it's a negative infinity and 2, negative infinity and 2. Here, negative infinity, always in any question, it's opened from the side of negative infinity or positive infinity. What about 2? Check this one, inequality. Here, x smaller than or equal. Do we have equal sign here? Yes, it's a smaller than or equal. So it's closed from the side of 2. But if it was only x smaller than 2, the domain will become like that, negative infinity. And also 2 opened of negative infinity by default. But from the side of 2, because it's only smaller than 2, so this means 2 not included. There is no equality sign, so opened also from the side. Okay. Another
مستر
point of the domain. Yes.
عشان اتاكد انا فهمت حضرتك، يعني لو الرقم اصغر من 2 يبقى البراكتس اوبن.
Exactly.
تمام.
If it's only smaller than, so the interval is opened from this side. Only smaller than or only greater than. But if there is equality sign, smaller than or greater than, whenever you see that symbols, this means it's closed from that side. Okay?
تمام يا مستر.
Okay. So now I will clear this one and get back to my question one more time. Okay. Guys, I want to write down the domain with different formula. I will write like this, domain equal. I just said that the domain is this area, right? So this means if I want to say that it's the whole real numbers, all real numbers except difference. Okay, which area not included in the domain? Actually, this one. Till positive infinity. So difference 2 and infinity start with the smaller element. So difference 2 and infinity. Infinity, as I said, always open. Whatever, positive, negative, always open. But now, 2. Now we will exclude this elements which is not belong to the domain. To belong to the domain or not? Yes, it's belong to the domain. So do we supposed to exclude it? No. Then opened from the side of 2. So domain equal this area or all whole number except this part. Okay, clear? Any questions, guys? Any questions?
No, miss.
Okay, great. Okay, great. So that was the polynomial functions and the types of the polynomial functions. We discussed the domain. Then what about the fractional functions or the rational functions? Rational function means f of x equal function on the numerator. I will consider that it's a k of x over L of x. Okay, so this means it's in the form of a fraction like that. X minus 1 over x squared minus 5x plus 6. And this one f of x, for example. How to get the domain for this function? Actually, guys, we studied that before in preparatory 3 on the second term. The domain of the fractional function equal what? Domain equal real numbers difference the set of zeros of denominator. Okay, what do you mean by the zeros of the denominator? Simply, I mean to that the numbers which makes the denominator equal 0. Its name is 0 of the denominator. Okay, So how can I get the zeros of the denominator? My question, at which case this one will equal 0? I will say that x squared minus 5x plus 6 will equal 0. If I will factorize this one, then x and x, then find the two numbers, their product is 6 and their sum is 5.
2 3.
Okay, so 2 times 3. Actually, their product is 6 and their sum is 5. Now, about the signs. The last term is positive. It was positive 6. So middle term is negative. So in this case, the two numbers will be like the middle term, negative, negative. So x will equal 2, x will equal 3. So in this case, domain will equal real numbers except these two numbers, which makes the denominator equal 0, the zeros of the denominator. So real numbers, the difference 2 and 3. Okay, guys?
Okay, miss.
Clear?
Yes.
Okay, let's solve one question like this. Find the domain of f of x equal 1 over x. Okay, here. We said that domain equal real numbers, the difference, the set of zeros of denominator. Okay, so now, zeros of the denominators, the only value which makes the denominator equal 0 is 0. So here real numbers, the difference is 0 only, because fx equals 0, so this means it will equal 1 over 0, so meaningless, not defined. Another question, f of x equal 3 over x minus 2. Now get the denominator, x minus 2 will equal 0, then x will equal 2. The domain will equal real numbers, the difference 2, because the value 2 or the number 2 is the only value which makes the denominator equal 0. Check that. If the x equals 0, so 2 minus 2 will equal 0. So the function will be 3 over 0, not defined. That's why we excluded that one from the domain. So we exclude the zeros of the denominator, or in other words, we exclude the numbers or the values which makes that denominator will equal 0. Okay? One more question. F of x equal x minus 1 over 2x squared plus 5x. Now, get me the denominator, 2x squared plus 5x. Okay. When it will equal 0, now factorize. There is a common factor, of course, it's x. So x times 2x plus 5 equals 0. Now, two values, this one and this one, their product equals 0. So simply this means that the first value will equal 0, or otherwise the second value will equal 0. So 2x plus 5 will equal 0. Therefore, 2x will equal, shift this number to the other side, change the sign. It was positive, then it becomes a negative. So 2x will equal negative 5. So simply x will equal negative 5 over 2. Exclude these two numbers from the domain. So the domain will equal real numbers, the difference 0 and the negative 5 over 2. I'm done. Okay.
Okay.
Okay. Another example. F of x equal x plus 1 over x squared minus 4x plus 4. Now, get me the domain, the denominator, sorry. X squared minus 4x plus 4 equals 0. Factorize x and x. Two numbers, their products 4, their sum is 4. 2 and 2. this one is positive. The two signs are like the middle exactly. Negative, negative, x will equal 2. So this is the only value which makes the denominator equal 0. Then exclude it from the domain. Domain will equal all real numbers, difference or except this 2. Clear, guys? Any questions?
No, ma'am.
No.
Okay, great. The next one, concentrate very well. The next point or the next question, f of x equal x over x squared plus 25. Okay. Now, the denominator actually is x squared plus 25. Okay, x squared plus 25 equals 0. Therefore, x squared will equal negative 25. Then x will equal positive or negative square root of negative 25. In this case, I have to say that this one not belong to the real numbers. Therefore, domain will equal all real numbers without any without any what? No number will make the denominator equal 0, of course, correct? So there's no exclusions. Okay, guys?
Okay.
The domain here in this question equal all the real numbers. Nothing at all will make the denominator equal. Try any number, x squared plus 25. Okay, whatever the value of x squared, if x equal positive, negative, 0, there is a value for the denominator. That's why I said that domain will equal real numbers. Okay? Clear? The next question?
تمام.
Okay. Next question, f of x equal x minus 3 over x squared minus 5x plus 6. Denominator x squared minus 5x plus 6 equals 0. Factorize 2 brackets equal 0. X and x. Two numbers, their product 6 and their sum is 5. Product and their sum is 5. So 2 times 3. And this is actually true. 2 times 3, their product is 6, and their sum 2 plus 3 is 5. Now, the sign, the last sign is positive. So the two signs are like the middle, negative, negative, x equal 2, x equal 3. This two values will make the denominator equals 0. So exclude them from the domain. Domain equals real numbers, difference 2 and 3. I'm done. Are we clear till this point? Do we have any questions?
لا
No.
تمام.
Any questions, guys?
لا تمام يا مستر.
Okay, great. Okay, the third type is the nth root function. Okay, if there is a function f of x equal root n of h of x. Okay, now, the first case, if this number n is odd number, therefore, the domain will equal real numbers. Why? Because here, if h of x is positive or negative, and this one is odd, means that this one is cubic root. So cubic root for positive or negative, we will get a value like cubic root of 8 equal to. Also, cubic root of negative 8 will equal negative 2. So there are real values. So no problem from the side of the cubic root. Cubic root means power. The index of the root is 3, and then n is odd. Second case, if it's a square root. In other words, I mean that if it's the index is 2 or even number. Okay, let's check. The second case, if n is even number, so this means the domain will equal all values satisfies this function h of x greater than or equal 0. Why there is a condition? Because this one is a square root and this function or this value must be positive. Otherwise, if it's a negative, there is no negative square root, okay? Or there is no real number as a root for a square for a negative number, correct? So this means the relation or the function on the square root must be positive number. So all values which satisfies the relation of the function greater than or equal 0. Now I'm going to solve some examples to explain it well. If f of x equal square root of x plus 2. Okay, now n here equal, this one is square root, so 2. So n equal 2 means even. So there is a condition. H of x greater than or equal to. Now this one h of x. So x plus 2 greater than or equal 0. Now shift 2 to the other sides. Therefore x will be greater than or equal negative 2. Okay, so simply what will be the domain? Domain will equal all negative numbers, difference, negative infinity first, greater than negative 2, sorry, and infinity. Negative 2 here, it's closed, okay, because it's a greater than, so closed from this side, and the infinity opened. Okay, guys, this question is clear?
Yeah.
Okay, the next one. If there is another function like this, f of x equal square root of x squared plus 5. So simply, n here, or the index of the root, is 2. So this means even. So the function x squared plus 5, h of x, must be greater than or equal 0. So x squared, shift this one to the other side. Okay, so the positive number will become the negative number. Therefore, x squared greater than negative 5. Okay, so what do you think? As there is a square root, this one is power 2. As there is a square root for negative number, no, negative 5 not belong to the real numbers. Therefore, there is no values will not satisfy the relation. In other words, the domain will be all real numbers. Okay? Any questions?
No.
Okay.
No.
Another question. If the question is like this, f of x equal negative 2x plus 3, and this one is square root. Okay, here the index of the root is 2, means even, because this one is a square root, so there is 2 by default as index, but we will not write it. Okay, so n equal to here means the index is even. So this function negative 2x plus 3 greater than or equal 0. So simply, guys, negative 2x greater than or equal negative 3. Now I'm going to divide the two sides by the coefficient of x, which is negative 2. In case of dividing the inequality or multiplying the inequality by a negative number, here negative 2 divide negative 2 means 1, and here will be x. Negative 3 divide negative 2 means 3 over 2. Okay, then what about the symbol? Dividing or multiplying by negative number means change the symbol. It was greater than or equal becomes smaller than or equal. Okay, So now, domain will equal real numbers difference. It's a 3/2 and smaller than, so I'm going to the negative direction, negative infinity and the 3/2. Negative infinity opened here, smaller than or equal, closed, done. Okay? Is it clear? Huh? Any questions?
No.
Okay,
No.
so don't forget a very important point. This one, if you will divide the inequality by negative or multiply it by negative, so change the symbol. It was greater than or equal, so it will becomes smaller than or equal. Okay? One more question. Very easy one. F of x equal 9 minus x squared, and this one cubic root. Okay, this one is very easy. N equal 3 odd. I don't care. Domain equal what? Real numbers directly. We said that if the index is odd number, so the domain is the real numbers directly. Okay, so nothing more? Yes, it's already done. The next question. Yes, Adam. Adam, yes. Any questions?
ايوه معلش حضرتك، هو بالرجوع للمسألة اللي فاتت الإجابة معلش
Okay.
كانت ايه بالظبط؟
And negative 2x plus 3, it was negative infinity and 3/2 closed from the side of 3/2 because it was smaller than or equal, and by default the negative infinity is opened. This one is real numbers difference. Okay,
تمام، هي مش المفروض open؟
just 1 second. It's all, it's this is what this will be the domain. Huh? Again, which one is opened? You mean 3/2?
3/2 كنت حضرتك عاملها
No, no,
R
no, no, no. No, no. It's not the real numbers difference. So this is only the values which satisfies the relation, not the whole real numbers except this one. I was mistaken in that point. It's only this interval is the domain.
ايوه تمام.
Okay, that's
Okay.
why I wrote it as a closed interval. Okay.
تمام اوكي.
Okay. The next question. If there is 4x squared minus 12x plus 9, and this one is a square root. Now, n here equal 2. So even, because it's a square root. So simply 4x squared minus 12x plus 9 greater than or equal to 2. So now factorize this one, 2 brackets, 2x, 2x. Two numbers, their product is 9, 3 and 3, and then check the means and the extremes. The last term is positive, so the two terms will be like the middle. Now this one negative 6x and extremes and negative 6x. If I will add these two terms, it will equal negative 12x. Actually, this one is the middle, correct? So my factorization is correct 100%. Now, it's 2x minus 3 times itself. So this means it's 2x minus 3 all to the power 2 greater than or equal 0. Okay, my question now. Can we suppose that this value will equal negative under any circumstances? Of course, no. Why? Because it's to the power 2. So this bracket, even this value is positive, negative 0, it will be greater than or equal 0. So in this case, the domain will be the real numbers. No exclusions. Okay?
Great.
Clear, guys?
Mm.
Okay, the next question. If there is a question like this, f of x equal x squared minus 4 square root. Okay, now n equal 2, even. Because this one is square root, this one is 2. The index is 2. Okay, so this means x squared minus 4 greater than or equal 0. So now I will factorize this function. X squared minus 4, it's a difference between two squares. So x minus 2 times x plus 2 greater than or equal 0. So simply, guys, here will x will equal 2 and here x will equal negative 2. So the solution set for this inequality, it's a function like this, and there are two roots. Here negative 2, here 2, just 1 second, 2, and here negative 2. Y or f of x here, what do you think? It's a positive, and also here positive. Okay, all this place is positive because here y is positive. Okay, but blue here, it's a negative. So in the middle between these 2 points, it will be negative. Okay, so now I want to get the solution which satisfies the inequality greater than or equal 0. So simply this means greater than or equal 0 starting from this point till positive infinity and starting from this point till negative infinity. So now what do you think about the solution set? It will equal the two, or the union of the two green area, or in other words, we can say that it will equal the whole real numbers difference the area on the middle, correct? Because it's a negative. So the real numbers, the difference, negative 2 and 2. And it's opened, of course, because at 2 and negative 2, the function equals 0, which satisfies the condition also here of the inequality. So here, real numbers, difference, negative 2 and 2, okay? And then this time, the domain will equal this one also. So this is also the domain. Okay, guys? Clear?
Clear.
Okay, great. Okay, one more question before the last point, which about the piecewise function. Last question at this point. The function here, f of x equal 1 over 4 plus 3x minus x squared, and this one is square root, like this. Okay. So now, this function, actually, it seems like a fractional function. So also I care about the denominator, right? So now, the index is 2. Index or n equal 2 because it's a square root. So even, okay. So now 4 plus 3x minus x squared must be greater than or equal 0. Okay. Now I'm going to arrange or rearrange these terms starting with x squared, then x, then the absolute term, so that I can factorize it. So it will become like that, negative x squared plus 3x plus 4 greater than or equal 0. Are we correct till now?
Yes.
Okay. But there is one small mistake
أيوه.
here, guys. I want to ask you a question because there is a small mistake here. Is it greater than or equal 0 or only greater than 0?
Greater
As we know,
and equal 0.
or equal? Okay, 1 second. Let's revise this point. As we know before, if it's a square root as a numerator, it's a greater than or equal, because if the square root equals 0, so this means that the function will equal 0, so there is existing value. But in the denominator, what do you think if the denominator equals 0? It will be 1 over 0, so meaningless, right? So in this case, we will just say it will be greater than 0. Right?
Yes.
Because here 0 is not possible to be a value for the denominator. Am I correct, guys?
Okay.
Is it
Yes.
possible to get 0 here? No.
مع-
So just
قطع.
greater than
ممكن
0.
تعيدها؟
Sure. Again, as we know that square root must equal a positive number or 0 so that we can get a value. I mean, square root of 0 equals 0. Okay, no problem. Or otherwise, the square root of positive will equal 2. So we will get a value. No problem. So we said that there is one condition. The value of the square root must be greater than or equal 0, right? But here, take care. The square root on the denominator, right or wrong?
Right.
So, is it possible to say that the square root value on the denominator equals 0? Can we suppose that this one, is it allowed to say that it will equal 0? No. Why? Because the function in this case will be 1 over 0, not defined, right? So in this case, it must be only greater than 0, so that the denominator not equal 0, right?
Mm.
Is it clear now?
Yes.
Okay. So now,
تمام.
there is one small problem here in this inequality. Actually, it's a negative x squared. So from my side, I have to multiply it by a negative 1, actually. Why? So that this sign will become a positive so that I can factorize it. Okay? So now, x squared minus 3x minus 4, I will multiply it by negative, so smaller than 0. I changed the symbol because I multiplied the inequality by a negative number. Correct, guys?
Yes,
Mm.
Miss.
Okay, now factorize 2 brackets, smaller than 0, x and x. Two numbers, their products 4, their difference is 3, 1 and 4. The last sign is negative. The greater term within the same sign of the middle. So greater term of 4 will be negative. This one will be positive. So the two values of x now, negative 1 and 4, right?
Yes.
Okay. So now, what do you think about the domain? The domain will equal domain greater than or equal, greater than real numbers difference, smaller than or equal, smaller than interval directly. So in this case, it will equal negative 1 and 4 and smaller than. So in this case, open. Okay, guys? Clear?
Yes.
Great. See.
Great. So just 1 second. I'm going to write down some main points from the last year. If there is equation ax squared plus bx plus c equals 0, okay? No, I meant inequality, sorry. Inequality like this. If it's a greater than, the condition is greater than or equal 0. So the domain on the first case, I will write it down here, greater than or equal 0. So in this case, real numbers, difference, open the interval of L and M. L and M are the two roots of this equation. If it's only greater than 0, so simply real numbers, the difference, close the interval of the two roots. If it's smaller than or equal, directly the interval L and M. If it's smaller than only, directly the interval L and M, but opened. The 4 cases for the inequality. Okay, guys?
Okay.
Okay, Mr.
Because actually, if this one on the number line and the function is like this, if the function is positive here and here, therefore it's a negative here, this root is L, this root is M. So if it's a positive or greater than or equal 0, so this means I'm looking for this area and this area, which means whole numbers or the whole real numbers except this part, the green one. So it's real number difference this area, which is open the interval of L and M. If it's only greater than 0, not equal, so in this case, I have to start from here after 0 and here also after 0. So it's the real number except this part from here to here. So real numbers difference, the 2 roots, but closed because the 2 roots not included. Okay? If it's smaller than or equal 0, I mean here the negative area. Negative means here between the roots of between the 2 roots. Smaller than or equal, so this also included. So L and M closed. Not equal, only smaller than 0. So the area in between only L and M, but opened from the 2 sides. Okay? This one is clear now, guys?
Yes, Mr.
Okay, great. So now the last part, and then we will finalize the session. It's about the last type of the functions. It's the piecewise function. Piecewise function. What do we mean by piecewise function? Actually, piecewise function, guys, it's a function that defined by different rules for different domains. Okay? So this means if the function is like this, f of x will equal, it will equal 2 minus x if x is smaller than 0 and x minus 2 at x greater than 0. So 2 different values for x and the function, also 2 rules for the function. Now, how can I get the domain for this function? Actually, this function defined on 2 intervals. If x smaller than 0, look at this part, x smaller than 0. So this means x belongs to this interval smaller than 0, so means negative infinity and 0, negative infinity opened, here smaller than only, so also open. The second one, x greater than 0, so this means x belong to 0 and the positive infinity, and the positive infinity is opened, and here only greater than, no equality, so opened from the side of 0, right? So the domain of this type of functions will equal, one second, the first interval is like this, 0 and the negative infinity, if this one is 0 and this one negative infinity, so simply it's opened from the 2 sides and shade the whole negative direction. The other interval is like this, it's also 0 and opened. I will use a different color. 0 and opened, and also shade the positive direction like this. So the domain here, guys, is this part and this part. So what do we mean by and or plus? So simply we can say that domain will equal this interval union this interval, negative infinity and 0 union 0 and infinity. Okay. One of you will say that, Mister, there is one important point here. You said that after 0 directly in this direction, before 0 directly in this direction. Okay, so you mean that the domain will be real numbers, the difference, the element 0? Yes. Clear, guys? Huh? Actually, I'm done. This question finished. Is it clear?
تمام.
Okay, great. Okay, next example. If the question is like this, f of x will equal x squared, fx greater than or equal -2 and smaller than 2. Also, it will equal x, and x will be greater than 0 and smaller than 1. It will equal 1 over x at x greater than 1. Okay. So now, the function here, f of x, is defined on 3 intervals. Let's check the 3 intervals. The first one, x greater than or equal -2, x belonging to, greater than or equal -2, smaller than 0, greater than or equal, closed, less than 0, opened. Why closed? Because or equal. Why opened? Because smaller than only. So this is the first one. Second one, x will belong to x greater than or equal 0, the smaller one first, and smaller than or equal 1, greater than or equal, smaller than or equal. The interval from the two sides is closed. Okay. Now the third one, x greater than 1. So this means it's starting from 1 and going to the positive direction till positive infinity. So x greater than 1, 1 and infinity. It's only greater than, there is no inequality. So, sorry, there is no equality. So open from the side, and by default from the side of infinity. Now, what will be the domain? It's the union of this interval and this interval and this interval. How to get the union of these intervals correctly without any mistakes? Represent each interval on the number line separately, like this. The first one. This number is -2. This number is 0. Okay, now guys, it's closed from the side of -2, so shaded. And opened from the side of 0, unshaded. Then shade the distance between them. The next number line or the next interval, concentrate well. 0 and 1. Okay. 0 will be on the same location of this 0. I mean to that it will be here 0. And 1. Where is that one? Is it here on the right or on the left? Of course, on the left. So 1 is here and also before -2, correct? So this is 1. Now it's closed from the two sides. Shade the 2 points and shade the distance between them. Okay. The last interval or the last one on the number line, it's 1 and infinity, 1 here. So it's opened, unshaded. And infinity as positive. Shade the whole direction. So simply now,
Zero.
what will be the union of this interval? The intervals begins from the end point on the left side from -2, and it's closed, so -2, till the end point on the right side, because here the union means all this part, right? So from -2 to infinity, closed from the side of the -2, opened from the side of the infinity, and now this one is the domain. Okay? Is it clear?
Okay.
Any questions?
No.
No.
Okay, guys, actually, that was the last question in the first part of lesson 1. Hopefully, all of you understood every point. Thank you for your time, guys, and see you on the next session.